Yes, so before we go to the properties of region of convergence, let us take few more examples so that the region of convergence is better understood. Okay, right. So we will take first example. So these examples are important, so please pay attention. Okay, so let us take first example to be x of t equal to, let's say, e power minus 2t u of t plus, or I'll take minus. Okay, so e power minus 2t u of t minus e power minus 5t u of t. So we'll take that as the first example. So we want to find what the Laplace transform of this signal and also find the region of convergence. Let us plot the region of convergence also. So for this, what will happen to x of s? X of s would be equal to, so first fellow will have, as usual, this is looking like what, e power minus at u of t. So that fellow will have 1 by s plus 2 as the Laplace transform with ROC real part of s greater than minus 2. Okay, this fellow will have minus 1 by s plus 5, because minus is there, you will get minus because of linearity property, which we will see later. Okay, so second fellow will have 1 by s plus 5 as a Laplace transform with ROC real part of s greater than minus 5. Okay, so this should be equal to what? We'll write it again. So if you simplify this, you will get s plus 5 minus of s plus 2, which should give me 3 whole divided by s plus 2 multiplied with s plus 5. Okay, so that would be the overall Laplace transform of the signal. But what happens to the overall region of convergence? So first fellow will have real part of s greater than minus 2. Second fellow will have real part of s greater than minus 5. When will both converge here? We will write down that. So first fellow, what will happen? It is real part of s greater than minus 2. So just for understanding, we'll write down. Let's say this is our real line. Okay, so let's say this is minus 5 and this fellow is minus 2. So just for understanding. Okay, yeah, so real part of is greater than minus 2 means this one, and similarly real part of is greater than minus 5 means this region. Okay, so when will both converge? Okay, so let's say this is the region of real part of is greater than, just for symbolic representation. Okay, and this is the region where real part of is greater than minus 5 will converge. When will both converge here? Both will converge only if real part in this region, which is nothing but real part of is greater than minus 2. So what will happen to the overall ROC? That would be real part of s greater than minus 2. Okay, so that is the Laplace transform of the signal with corresponding ROC. What is that? If x of t equal to e power minus 2t u of t minus e power minus 5t u of minus t, then Laplace transform is given by 3 by s plus 2 divided by s plus 5. Let us plot the region of convergence now. So to plot the region of convergence, we should take the help of the S plane. Okay, so this is sigma and this is j omega. So this fellow has one pole at minus 2. Let's assume this is minus 2, another pole at minus 5. So we have a pole at minus 2, we have a pole at minus 5. So what is ROC here? ROC is real part of s greater than minus 2. So ROC is real part of s greater than minus 2. So this is the region of convergence for the given Laplace transform. Okay, now let us take same example but a little bit change. We will take that as the second example. Okay, so one more example, which is x, let me call this as x2 of t, and previous signal let us call it as x1 of t. Okay, so x1 of t will have x1 of s as the Laplace transform, which is 3 by s plus 2 times s plus 5. Okay, now let us take second signal x2 of t, which is equal to, let us take this to be e power minus 2t u of t. Okay, plus I'll take e power, let us take 5t. u of minus t. Okay, so this should be e power minus 2t u of t plus e power 5t u of minus t. Okay, now or I'll take minus itself here. Okay, so what is the signal here? E power minus 2t u of t plus e power minus 5t u of minus t. Okay, so what will be the corresponding Laplace transform? X2 of s. We'll repeat the same thing what we have done before. So you pay attention for the example. So you will get 1 by s plus 2 because first fellow did not change. What would be ROC for this fellow? It is real part of s greater than minus 2. So this fellow is looking like what here? Minus e power minus at u of minus t. So this should be equal to minus 1 divided by, correct? So you have minus, you will get minus 1 divided by s plus 5. But what happens to the ROC for this fellow? That should be real part of s less than minus 5. Okay. Yes. So before we write down the expression for x2 of s, let us just see what happens to the region of convergence. So this fellow is let's say again this is minus 2 and this is minus 5. Okay, yes. Okay, so first condition ROC of first Laplace transform would be real part of is greater than minus 2, which is like this. Okay, so this is real part of s greater than minus 2. This fellow is what here? Real part of s less than minus 5. So real part of s less than minus 5 will look like this. Correct? This is the region where you have real part of s less than minus 5. When will both converge? There is no region where both will converge, and hence what do we say? This signal e power minus 2t u of t plus e power minus 5t u of t does not have Laplace transform. Okay, what does it mean? As there is no common ROC, there is no common ROC. Okay, the Laplace transform of x2 of t does not exist. Okay, Laplace transform of x2 of t does not exist. Okay, yes. So now let us take third example. Note that everything remains same except that I am doing the change of the sign. Okay, that you have to note. Third example, let us take x3 of t to be equal to, let me take minus e power minus 2t u of t plus e power 5t minus 5t u of minus t. Okay, yes. So for this, what will be our x3 of s? That should be equal to, sorry. So that, okay. So this signal, పద తొందరగా తొందరగా వెళ్ళిపో ప్లీజ్ తలిపి. Yes, now let us take third signal to be x3 of t, which is equal to minus e power minus 2t u of t u of minus t, and the second signal let us keep it to be e power minus 5t u of minus t. So what will be x3 of s? This fellow will have 1 by s plus 2 with Laplace and with the ROC real part of s less than minus 2. So this fellow will have plus, sorry, this fellow will have minus 1 by s plus 5 with ROC real part of s less than minus 5. Okay, yes. Now again before we do that, okay, so let us write down what is x3 of s. Okay, so x3 of s would be again as usual, you will get to 1 divided by s plus 2 multiplied with s plus 5. But if you want to find the overall ROC, again we have to draw the real line. Let us draw that. So again this fellow is minus 2, this fellow is minus 5. Okay, so first fellow has ROC to be real part of s less than minus 2, which is this region. Okay, let me draw the shaded region like this. Okay, next second fellow will have real part of s less than minus 5. So what is that region here? Real part of s less than minus 5. So this is the region. So when will both converge? When will both converge? Both will converge when real part of s is less than minus 5, and hence what happens to the ROC? ROC would be real part of s less than minus 5. Okay, right. And let us draw the region of convergence again. Okay, so to do that we should know the pole zero diagram. So this is sigma. Note that I am not mentioning what is pole zero diagram. I should have studied in control systems. Okay. Yeah. So this fellow is minus 5. We have a pole at minus 5 and we have a pole at minus 2. So what is ROC? It is real part of s less than minus 5. So what is that region? This is the region where our Laplace transform converges. Okay. That is the ROC of the given Laplace transform x3 of s. Okay.